All right, so first one is going to be letter A. Letter D is Newton's first law. Letter B is Newton's third law. Letter C, they said mass divided by acceleration to find force. If you cover up F, it's mass times acceleration to solve for force. So A is going to be our guy. Number 2, objects that accelerate are undergoing a change in their motion. How can this be done? How can objects change their motion? If they increase their speed, do they change their motion? Yeah. Okay. What about decreasing their speed, though? Yeah. What if I change my direction? Am I changing my motion? Yeah. So guess what? D. Accelerations are produced by not necessarily velocities, not necessarily masses, not accelerations, but by non-zero net forces. So remember, if the net force is 0 on an object, the acceleration is going to be 0. So it needs to be a non-zero, so something greater than 1, or 0, sorry. Something greater than 0 to cause an acceleration. So we're looking at letter B. Number 4. As net force increases, what happens to the acceleration? So basically, the harder you push, what's going to happen to the acceleration?
A.
Yeah, it's going to go fast. All right, it's going to increase. It's going to be the faster. When a net force acts on an object, its acceleration is in the blank as the net force. So let's say I push on an object to the right. Is it going to accelerate? Yeah, it's going to go in the same direction. Okay, so here we have our triangle. You're moving a dresser that has a mass of 36 kilograms and an acceleration of 1.5. What is the force being applied? So they want force. Which is equal to mass times acceleration. So for mass times acceleration, you're going to just take into your calculator 36, right, times what? Times 1.5, and that's going to crank out 54.
B.
Yes. So 36 times 1.5 is B. What?
On my screen, the FNet is all messed up.
I'm sorry. I'm sorry if the FNet is messed up.
No, you're fine. It's just my screen. Because like when I go into it, it looks perfectly fine. But when I open up my dock, it's all messed up.
That's annoying.
Yeah.
Number 7. 2 girls push a stalled car. Each girl pushes with 389 newtons of force in the same direction. What is the mass of the car if it accelerates at this? So for this, I would just draw a quick free body diagram. So I'm just going to draw a box, and I'm just going to talk about the forces that they tell us about. So 389 newtons of force. Is that my total force? Is that the total force? Is that the net force there, guys? No. Why? Because 2 girls push on it, and each one pushes with that. So there are 2 389s. So what is my net force then? I got to add them together. So 389 plus 389. So I have a net force of 778 newtons. That's F net. This is the acceleration. They want mass. So if I cover up M in the triangle, it is F net divided by A. So So I'm going to do 778 divided by 0.75. 1037.3 repeating. So we're looking at letter C.
Mr. Lombardo, Haley asked a question.
Okay. Give me a second. What was the question, Jay?
She didn't ask it on the chat.
You should. I have court. Can I leave?
Oh, I
Yeah.
just got it right now.
Yes.
Literally. just in front of
Yes,
me.
you can go.
I got it.
All right. So, excuse me. You have a 20 Newton falling object. It encounters 4 newtons of air resistance. What is the net force on the object? Well, I'm just going to draw myself a little free body diagram. If 20 newtons is the falling object, 20 newtons is its weight. And then weight is always acting downward. Air resistance would go against that, yes? And how much was that? Good, 4 newtons. So forces in opposite directions, what do we do with them? Subtract them. So 20 minus 4 is 16. Letter D. Okay, number 9, we get a sports car. Sports car has a mass of 1,500 kilograms, and it accelerates at this rate. What is the net force? So F net is our question mark. Cover up F net in the triangle, and that's going to tell us to multiply mass times acceleration. If they're next to each other, you multiply. Do we have both of them? Heck yeah, we do. So we're going to just plug it in and chug it out. 1,500 times 5. And you're going to get, and what is the unit for force? Newtons. So letter C. Tow truck exerts a force of 2,000 newtons on a car, accelerating it at 2 meters per second squared. What is the mass of the car? So again, now what are they asking for? They're asking for mass. So if I cover up M in the triangle,
Sorry.
M equals F net over A. And we are looking at 2,000 newtons over 2 meters per second squared. 2,000 divided by 2. I can't believe I just punched that into a calculator, but I did. 1,000. Now, what is the unit for mass? It is going to be these kgs. In this case, we're looking at letter B. All right, cool with those? Now, moving on to the next one. Ooh, this is a good one. This is a nice challenge question. If you pull horizontally on a 50 kilogram crate with a force of 450 newtons, and the friction force is 250 newtons, what is the acceleration? So I would say draw out a free body diagram. Unless they tell me the directions, I always like to make my pull or push force to the right. So I'm pulling with 450 newtons, so I'm just going to draw that to the right. And friction always goes against motion, so friction should go, in this case, to the left. What is the net force here? If opposite directions, what do we do with them again? subtract. So what's 450 minus 250? So the F net is 200. They want acceleration.
You gotta divide by 50.
Yep, A is F net, not F net divided by mass. So doing 200 divided by 50, and that is going to give me 4. The unit is meters per second squared. No, it wasn't too bad, right? I thought it was a little bit harder than I originally anticipated. Yeah. So pressure. We didn't really do too much with pressure, but I'm going to go over it now. Pressure is defined as force per unit of area. Force per unit of area. And it has a pressure, the unit of this pressure is going to be called a Pascal. Now the equation for pressure, it's force divided by the area. So which one of these, think, which one of those would exert the most pressure on the ground? A woman standing in high heel shoes, standing on running shoes, or standing on skis? So the way I would think about this is, if you have it, you take your hand, just zoom out for a hot second. All right, so the woman on skis, if you had your hand out and you laid your pen or pencil out, just press down with one finger. Shouldn't really bother you at all. All right, now if you take it and do like the bottom of it or eraser side, you press down, you'll notice it more, but still really doesn't bother you. And you put the point side down and just press down a little bit. You notice it a lot more. Why? You didn't really press any different. So the force would be the same. What's the only thing that changed? How much area was in contact with your hand. So this has the longest or largest area, so that'd be your skis. So that weight that you're pressing on, or the force you're pressing against, divided by a big number, you're going to get a small pressure. Now I make the area smaller using the bottom of it. Now it's not too bad. All right, I mean, it's still, you can feel it definitely more. It's more noticeable, but it's still not bad because it's got a decent area. Now you make the area very, very small, like the point, and you do the same brush, like the same force, and now the pressure goes way up. So now how would you answer that? Which one exerts the most pressure on the ground? Definitely the high heels, right? So we're looking at letter A. So if we have to determine the pressure of a 5 Newton book, if the length is 20.22 meters and the width is 0.09 meters. So first you got to figure out what the area is. Area is length times width. So I'm doing 0.22 times 0.09. And that is going to give me the area here of 0.0198 meters squared. That's our area. Cool. Force is 5 newtons. And so pressure, yep, force divided by area. So we're doing 5 divided by this number here, this 0.0198. I'm getting the 200, 525 or 523 or 525, whatever, and the unit will be in pascals, capital P, lowercase a, and the answer that matches that is letter D. Schwappow. Oh, this is a cool question. Okay, so if you're on a frozen pond and the ice starts to crack, you're going to want to do what? Don't want to run. All right.
want to decrease the pressure.
You want to decrease the pressure on the ice. It's the pressure that's going to wind up breaking the ice. So when guys like, there's sometimes cross-country skiers, right? They have those like big snowshoe things that are super wide area, and they do that so it takes their weight and spreads it over a larger area, so it's less pressure on the ice. Okay, and you have like things that have little spikes where if something has a very small area, it's able to create more pressure on the ice and it's going to wind up causing it to crack. So if you decide to run, when you run, do you run flat foot or do you usually run like the balls of your feet? The balls of your feet, right? So if this is like your foot, I'm going to draw a really bad foot. Okay, so there's your foot. Now when you're running, now usually you're on like the balls of your feet, right? Look at the area you've just done. You did what's the area? Did you make it bigger or smaller?
Smaller.
You've made it smaller, and your weight didn't change, so now the pressure's gone up. And generally when we run, usually 1 foot is on the ground at a time, right? I think. So now, instead of having 2 feet on the ground, now you only have 1, and you've made it even smaller. So you definitely don't want to run, okay? You want to try to do your best to slowly kind of get down, starfish yourself, all right, and kind of like army crawl as you starfish, Patrick Star away. The reason why you're doing that is because you're increasing your area, which does what? Decreases the pressure. Hell yeah. Excellent. Okay, what is the force that one surface exerts on another when the two rub against each other? Friction. You are. Hell yeah.
You finished that. What are we?
Huh?
You said you are, and then you said, hell yeah.
You are right. Okay. Which of the following statements is true about friction? Is static friction less than sliding friction?
No.
No, because think about it. It's harder to get something to start moving than it is once you get it moving. Let's see. D. Friction always acts in the opposite direction of motion. You are absolutely correct. It is. We can work through why. Friction acts in the opposite direction of normal force. So if we have a box or any object chilling on the ground, weight is directly downward always, and for a flat horizontal surface, the normal force is going to be going upward. And for any time it's on a flat surface, the weight and the normal force are equal to each other. Okay? The weight and normal force are going to be equal to each other. And anybody remember the definition for weight? It's an object's mass times gravity. So now, number 19 says the coefficient of friction, which is this little symbol here, mu, between two surfaces is 0.25. So mu equals 0.25. That doesn't have a unit. Now, a student attempts to move this mass of a crate, but it stays at rest. What is the friction force? Well, see how I put it right here? The friction force is going to equal the push force. Now, to get this into weight in newtons, you would take this times 10. So mass times 10 gives us 344. So if I just kind of drew this little picture. All right. So that means the weight down would be 344. And they tell us right here that the normal force is also 344. The F sub n. Okay. we want to know what is the friction force. Well, friction is the little f here. So if I cover up F, what does that tell me I got to do? F equals the coefficient of friction times the normal force. And I have both of them. Normal force is 344. Coefficient is this. So I'm going to do 0.25 times 344. And that's going to give me 86. Letter C. All right. A push force of 250 newtons is used to keep a 65 kilogram crate with a normal force of 650 newtons sliding across the floor at a constant velocity. Constant velocity means that the friction force is going to have to be the same as the push force because it's not accelerating. All right, it's moving at a constant speed. So we want to know what the coefficient of friction is. That's that little symbol U. How do I solve for that in the triangle? If I cover it up, what am I dividing? Good. F over Fn. And guess what? We have both of them. F is 250, and normal force is
650.
650. So just bang that out in the triangle, our calculator. 250 divided by 650. Oh, that is, I put 350. Well, that is not correct. That is better. And that is coming out to be a 0.384. So we're going to wind up going with letter B. So I guess technically if we wanted to round the 6 to the 4, this would make it a 5, and then that would round it up to a 9 if we were chopping it off at 2 decimals. So is that really bad, guys? You know what you're looking for, and you were given both of these guys. In the second one, they asked you to solve for friction. F, you were given coefficient, which is this little U guy, and the normal force. What is the net force on a crate if two movers apply 85 newtons and 52.5 newtons of force that go in the same direction while they encounter a friction force of 45.5 newtons? It acts in the opposite direction. So help by drawing the free body diagram out. Okay, so when doing that, you got the two movers. I'm just making it go to the right because I like that. So 85 newtons and 52.5. Now friction goes in the opposite direction, which was 45.5 newtons. Okay, so how do I figure out the net force? What do I need to do? If they're in the same direction, what do I got to do first? Add them. So what is 85 plus 52.5? So we have 137.5 newtons to the right. We still have that 45.5 to the left. Now, what do I do? If they're in opposite directions, I sub. Good. So it's 137.5 minus this guy, and I'm going to get a net force on this object of 92 newtons. So we're looking at letter A. All right, A. Okay. All right, let's roll through these true falses. The combination of all the forces acting on the object, is it called the net force? Is that true? Mm-hmm. The net force on an object falling at terminal velocity is 0. So remember, when something is falling at terminal velocity, that means it's reached its max speed. So it's no longer increasing its speed. So that means the velocity would be constant. If the velocity is constant, what does that mean the net force has to be? 0. So
0.
the net force of an object following a terminal velocity is 0. That would be true. Acceleration of an object is inversely proportional to the net force acting on it. So inversely, guys, means as one increases, the other decreases. So think about it logically. If you increase the net force, what happens to the acceleration? So like the harder you push something, the greater the acceleration should be. This is trying to tell us that the acceleration is inverse. So if I push harder, the object would go slower. Yeah, so that means that would be false. A fluid can either be a liquid or a gas. Oh, well, we didn't really fully go through and mention it, so you won't have to worry about that being on your test tomorrow, but we're just going to say that that is true because technically it is, but you're not going to need to know that.
Isn't that basic science?
Well, maybe, but if you haven't talked about it in a while, you usually forget it. Because in our everyday vernacular, when we talk about fluid, we think of liquid. All right, but it can be a liquid or a gas. 5, one of the factors determining friction are the type of materials that are in contact. So think about tires on concrete versus tires on ice. Does that play a role in friction?
Yeah.
Yeah, so
Yes.
then that would definitely be true. Pascal, is that the unit of force? Hell no.
No.
Absolutely not. Objects will only accelerate when a non-zero net force acts on them. So what that is saying is, remember, when we did the equilibrium thing, anytime an object is in equilibrium, what was the net force? Always 0. So you can have something at a constant velocity, but then the acceleration would be 0, which means the net force would have to be 0. So the only way to get an object to accelerate is to have a net force on the object greater than 0. So the only way objects will accelerate is when a non-zero net force acts on them. True. Free body diagrams show all the forces acting on the object. Hell yeah. Yep, absolutely. Number 9. Pressure is defined as the total force acting on an object. No, what do we call that? The total force on an object. We call that net force. So yeah, you're false. Number 9. Goodbye. Pretty sus over there. Number 10. The air resistance force of an object depends on the object's speed and area. That would be true. But you're really not going to need to worry about that for the tests or for everything else. Yeah, I would expect something similar too. Okay, these guys, you guys know how to do this. You have your triangle, you have everybody. We did an exact problem worksheet just like this. Okay, so I have no problem. You can do this. I did want to show this though for a specific reason. I had a student a couple years ago try and tell me that the last time Halloween was on Friday the 13th was in 2003. Right? Does that make sense? You think it was probably 2003? That the last time the Halloween was on Friday the 13th?
No.
Every 7 years.
Yes, it happens every 7 years. What? No. Because the kid came in one day and tried telling me that
Oh, or 13.
that was the thing, yeah.
I'm thinking you said Friday.
Yeah, so I was like, all right, bud. I showed him like a calendar. I showed him 3 calendars, and I was like, what day is Halloween on in each of these? Oh, it said the 31st. But that's just this year's calendar. So I went back through old calculators, and I showed him, and I even went back to that day, and he's like, oh. Like once it clicked, you could just see the shame. It was pretty funny.
I was so confused.
I thought he was gonna double down.
Yeah, no. I was like, where did you hear? He's like, oh, it was on Twitter. I was like, okay.
That is a pretty good brain to
No, it shouldn't be. But I think everyone's nowadays is just so like, they hear things, they think fake news, and they're like, okay, I accept it. It's got a flashy headline.
Well, you just say Friday the 13th, they think of Halloween, so it's like.
Maybe that was it. All right. So guys, this problem looks like a beast. Pretty simple, actually. Okay. I don't know why this came out really, really tiny, but acceleration is equal to the total force divided by the mass. So the force is the force of the hanging masses, or the weight of the hanging masses, divided by the total mass of everything. So someone real quickly add 3, 8, 6, 5, 17, 35, and 45 together. Because those are the masses of everything. What is that? That comes out to be 119, I believe. Yeah. And then the weight of the hanging masses. So the weight is equal to mass times gravity. These are all masses. I can take these times 10 individually, or if I just add these three together first, that would be 97 kilograms, which I can then do times gravity. And that comes out to be 970 newtons. So 970 divided by 119. .15 meters per second squared. Not too bad, right? Okay. So, guys, this is like a practice test. So, between the stuff that we just did today and some of the stuff that were on the quizzes yesterday, all right, that's going to be the stuff that's going to be on your test tomorrow. Got it? So, I think it would be beneficial to have written this out or have completed it on your Google Doc kind of a deal, because I can wind up making it open notes. You can turn it in, or you don't have to. You can turn it in tomorrow after the test. Okay, but please make sure that